Hey guys, right, welcome to another video. Um, Obviously very close to the exam and this topic is quite difficult, so I thought I'll do a quick one or two videos on this. What we'll try to do is mainly focus on the past paper questions from Rocket Revise. So I'll try to go through the formulas for, the first few minutes, and then we'll go straight to the Rocket Revise topical questions. I'll go through those in detail and you can then try some on your own, so on, right? So work energy power, what you're supposed to do here is make sure whenever you see a question on work energy power, just write down the formulas first, see what fits into the formula, and then go from there, right? So two formulas which we'll use. One is this one here. So work done by driving force minus work done by resistance equals KE change plus GPE change, right? So kinetic energy and gravitational potential energy. And I'll just show you what the formulas mean. So work done by driving force means um, driving force times by the distance. Right? So I'll write distance here just to not confuse it. Now, they might say work done by the man or work done by the car. And that basically means work done by the driving force of the car or the pushing force of the man. So it's basically the same thing as work done by driving force, right? Work done by resistance is um, resistance times the distance. Okay. Now I'm going to change this to D because we will use that in the diagrams and it will just make it easier, right? Equals to KE change. Now you should know this by now. That's half mv square minus half mu square. Okay. And gravitational potential energy is m times g times h. Okay, now one thing to note, gravitational potential energy can be negative, right? If the object is moving down or sloping down, then this is going to be negative. Okay, so make sure you don't forget that. A lot of people make a mistake with that, right? Now, just to go into these in more detail, let's say an object is traveling from A to B, right? Now, this distance from A to B is your D. Okay, so this is the D we use over here and over here. Okay, the H, which was here, is the vertical distance. Okay, so H is going to be this one here. Okay, so you might have to calculate this using SOHCAHTOA sine cos tan. Right now, in this particular case, we're going from A to B, so this is upwards, right? That means GPE change will be positive. Okay, if you were going downwards, okay, let's say you were going from B to A, then your GPE change will be negative. So that's the only difference. Okay, now if an object was traveling horizontally, right? So this is D and H will be 0, right? Because there's no height. Okay. So you just have to consider T. Other things that will come up, if a surface is smooth, that means resistance is 0, right? So this will be 0. So the work done by resistance is also 0. And another thing to consider was sometimes instead of resistance, they'll give you friction. So you just replace this with friction and replace this with friction. That's all it is. Now, the formula for power is now power is not in every question, right? So you don't have to use the power formula for every question, but if they do mention power, then obviously you have to use it. So power is equal to driving force times velocity, right? dF is driving force, this one. Right? So driving force times velocity. Okay, that's the full form in case you want to see it. I just prefer writing dF times V. It just makes it more easier. Right. So the strategy is write whenever you see a question on work, energy, power, write down this formula. And if the question mentions power, write down this one as well. See which ones of these values we can fit in, which ones are missing, and then do some calculations, right? So we'll start off. Okay, so this is question 1 from the Rocket Revised Topical Work Energy Power QP1. Pause the video, read the question, and we'll go through it. Okay, so first one, easy, simple, right? Kinetic energy. So that's going to be half mv square minus half mu square. Okay. Now this is the starting speed at P. This is the final speed at Q. Okay, so half times 4, which is the mass, times 12 square. Right, so calculate this. It should give you 160. Sorry, minus 160. Okay, that means the loss is 160, and when we put this in the other formula, right, CAIE change is negative, so we will use negative 160. Okay, now let's go to part B. Okay, so we've got this now. Let's see what values fit into here, right? Now, it says find the work done by the force pushing the block up. Right, what does this mean? This is basically the same as work done by driving force. Okay, they've just said it or written it in another way. So this is what we need to find. Okay, so now let's see which values we have here. Yes, so I'm going to leave this as it is because this is what we are finding. So work done by driving force, okay, minus work done by resistance. Now, this is a smooth plane. That means there is no resistance. So 0. Okay. KE change was minus 160 and GPE change. Now, it's being pushed up, right? That means that's going to be positive GPE change. We need to calculate it. So, okay, so this is slightly tricky. So P and Q are 10 meters apart. What does that mean? Right. What that means is, okay, let's just write this here. Now, GPE changes M times G times H. So M is 4, G is 10, H we don't know. Okay, so let's calculate H. So using the information we have, P and Q are 10 meters apart. Okay, and it's 30 degrees. Sorry, yeah, so that's 30 degrees right now. Using SOHCAHTOA, we can find our H that we need, right? So we have opposite which is h, and hypotenuse is 10, right? So sine 30 equals opposite over hypotenuse. So h is equal to 10 times sine 30, which is 5. Right now, once you've got h, you replace h in your formula with 5. So I'm just going to rub this off. Now, what does this give you? Work done by driving force minus 0, so that's just gone. Minus 160 plus all of that gives you 40. That's your answer. Okay, so that's part B, and let's go to part C. Okay, 1C is over here. Right, now, this question is asking you for the time taken, right? Now, straight away, I know I'll have to use the SUAT formulas at some point, right? Because the work energy formulas, they don't have time. Now, what's the question saying? The force pushing the block up is removed. Okay, so what that means is the driving force is no longer there. So the driving force is now 0. Okay, so we have P, Q, and the block is over here. Okay, just going to remove this just to make it easier. Okay, now there's no driving force, so that's just 0. Okay. And you have the, did we have a resistance? No, it was a smooth. Remember in the question it said it's a smooth slope, so there's no resistance, there's no driving force. The only force acting will be the weight. Okay. Now, this is going to be so here. Okay, so 4 kg, so 4g will be 40, and then you have here 40 sine 30. Okay. So this is going this way. Yep. So this is the component of the weight going parallel to the slope. So that's 40 sine 30. Okay, now the block, what was the direction of the block? The block was moving this way, right? From P to Q. Okay. Now the direction is not instantly going to change, right? It takes time for the direction to change, right? The particle comes to the stop and then it goes back and so on. So this is your positive, sorry, positive direction, right? Going from P to Q. So what we're going to do is we are going to do this way. That's your positive minus this way equals to MA. Right now, what's going up the slope? That's just 0. So 0 minus 40 sine 30. Okay, because that's the one which is going down, is equal to MA, which is 4A. And if you solve this, it will give you A equals minus 5 right? Once you've done this, they wanted you to find the time. Okay, so now in order to find um, the time, we will have to use the sweat formula. Okay, so um, right now the speed at Q was um, 8. Okay, from the question it said speed at Q is 8. So over here the speed was 8 and moving this way, right? Okay, now this is how we're modeling it, right? I'll draw this again. So we have P, Q. Okay, at the moment the block is over here. Okay, the speed at Q is 8 going this way. Okay, your distance here is 10. Okay, now from Q to P is downwards, right? So now what we're going to do is, remember we took this as your positive direction. Okay, that's because at Q, we took this as positive, right? Because at Q, your particle was still traveling upwards. Okay, so your uh, at Q, your velocity is 8 positive because it's in that direction. S is going to be minus 10. Okay, because from Q to P is downwards and our positive direction is upwards. Okay, so minus 10 equals 8t plus half. A was minus 5 and t square. Okay, and if you solve this, you get t equals 4.16. Okay. So this part was obviously slightly tricky with the plus and minus. Okay, so just to sort of reiterate that, um, what we did was it said the block is at Q and it's going to return to P. Okay. Now, when the block reached Q, it was still traveling upwards. Okay? It didn't instantly change direction back to P. Okay? So that's why we took upwards as our positive direction. Okay. So 8 was the velocity at Q, so that was upwards, so that's positive. And because P is below Q, your S becomes negative. Okay? Because S is your displacement. So whenever the final destination is below the initial destination, that means it's downwards. And in this case, downwards will be negative. Right, so let's move on to the next one. Right, so this is question 2 on the rocket revised topical. Okay, right, just before we sort of go into it, in terms of units, so energy is usually in joules, and power will be watts or kW. Because sometimes they won't tell you if it's energy or power, so then you tell from the units. Is it energy or is it power? Okay, so first question here. Again, so I've just written the formula. Now this is a sort of power question, right? So I've started with the power formula, and if I need the work energy formula, I'll put that here as well. But let's start with power and see where we are. Okay, so keywords in the question: constant speed means acceleration is 0. Okay. Now they want you to calculate the power, right? So power equals driving force times velocity. Velocity is 32. Okay. We don't know what the driving force is, so let's see if we can find the driving force somehow. So we have a resistance, which is 750. Okay, and this is your driving force. Okay, now your driving force will be 750, right? Because it's constant speed, which means A is 0, right? And it's a horizontal surface. Okay. Now this doesn't work for a diagonal surface. I'll show you anyway, right? So if you do F equals ma, right minus left equals ma, right? Now acceleration is 0, so ma just becomes 0, which means df is equal to 750. You put that into here, so 750 times 32, which gives you 24,000 watts. So 24 kW. Right? So K means 1,000. Okay, going to the part II. So the power is now reduced to, how much was it before? So it was 24. Now it's reduced by 8. Yep. So 24 minus 8 is 16. Okay, so the power is now 16,000. Okay, and your driving force will obviously change, and your velocity was 32. Okay, so velocity doesn't change because it's constant. So if the power is decreasing, then obviously your the force applied has decreased. Okay, so here driving force will be 16,000 divided by 32, right, which gives you 500. And then we work out the acceleration, right? Because that's what they want you to find. So this is your driving force. This is your resistance, which was 750 in the question, right? So right minus left is equal to ma. Your mass, which they gave to you, was 1250. Yeah. Okay. And then you use this, and if you solve it, your acceleration will be negative 0.2. Right. Going on to part B. Again, moving very quickly because, lots of questions to go through. So we are now on a road which is inclined. Okay, the last one was horizontal. They told you it's horizontal, right? That's why all our diagrams were horizontal. This one is inclined. Okay. Haven't given you the angle, they've given you the sine inverse, so we'll use that. But just putting theta there. Okay, so let's see what we've got. This is your car, that's your driving force. Actually, we might not need the diagram, so let's just see. Remember, always start with the formula, right? See what you need. Okay, so we might not need the full diagram. Just see what we need. So we've got, what part of this do we have? So they've told you the power, 60 kW. So that's 60,000. We don't know the driving force, and we don't know the velocity, right? Now, the velocity obviously we need to find. So that's going to be unknown anyway, but we need the driving force, right? So yes, you will need the diagram to find the driving force. Okay, so we've got the driving force there. Just write it. That's your driving force. And the resistance to motion is here, 1000 plus 8W. And what else do we have? The mass. Okay, so your mass was 1250. So your weight will be 12,500 and going down there. Okay, so this component going this way. 12500 sine theta. Okay. Now, so using your sort of F equals ma, and the car is going up the slope. So we do up the slope minus down the slope. Okay, so going up, we have df. Going down, we have this is going down, and this is also going down, right? So we're out of space. Okay, spread this. It's equal to ma, which means right. So it's constant speed, right? So constant speed means acceleration is 0. Okay, so ma will just be 0. Okay, now let's expand this out. So df minus 1000 minus 8v. Now 12500 sine theta. Okay, now they've told you this is your theta, right? So right now, if I do sine of that, right, what I'm doing is I'm doing sine of sine inverse 0.0, right? Because you see here we're doing sine theta. So sine theta means sine of sine inverse. Okay, now sine of sine inverse means it just basically cancels out. So you're left with just 0.096. Okay, and then you times that by the 12,500. Okay, now you put that into the equation, and that should give you 12,500 times 0.096. Right, so that's 1,200, 0. And you get, if you solve this, df equals this is what you get for df driving force, and then you put that into here. So yep, so you see before it was multiplied by v, right? So 2200 plus 8v times v, that gives you 6000 equals 2200v plus 8v squared. Okay, now make this into a quadratic and solve it, and you should get v equals 25. Okay, so Moving on to next. Okay, so this is question 3 on the topical rocket revise. Right, first question here. Now this is a power question. I've got the power formula, and if we need the work formula, we'll put it as well. Right, what's it asking you to find? It says find the power. Okay, so that will obviously be unknown. The driving force we don't have. The velocity is 30. Okay, so we need to basically find the driving force. Let's see what we have here. Constant speed. A equals 0, so that's basically job done for us. Resistance is 3000 horizontal road. Okay, so right minus left is equal to ma. Because acceleration is 0, that becomes 0, and so df is just 3000. Easy. Sorry about the writing. That gives you 90,000, which is 90 kW. Okay. Okay, next part here. Right, here I'll need the energy formula because it says use an energy method. Right, read the question yourself. Pause it, read the question, then come back. Right, so work done by driving force is what? Driving force times distance. Work done by resistance is what? Resistance times distance. Okay, CAIE change is half mv square minus half mu square. Okay, and GPE changes mgh. Okay, now be careful. Is it going up or down? It's going from A to B. So it's going up, right? So mgh will be positive, no problem. Right, so the next part is to fill all these values. Now, what's the driving force? Right, key information here, the driver switches off the engine. Right, if you switch off the engine, there is no driving force because you're not pushing the pedal. So there is no force pushing the car up, right? So that's just 0 times d, which is 0. Okay, what's the resistance? 3000. Okay. Now we don't have d, right? So let's just keep that as d. Okay, 0 minus 3000 d. I'm going to write this slightly better. Okay, minus 3000 d. Okay, equals half mv square minus half mu square. Okay. So half times, what was your mass? 25,000. Half times 25,000. Okay, you do this in your calculator, you should get minus 343. Right, and then we have mgh. Okay, so m is your mass, which was 25,000. Yeah, g is 10. So 25,000 times 10. Where were we? Messed it up. Yeah, sorry. So M is 25,000. Yeah. And G is 10. So 25,000 times 10 gives you 250,000. And we don't know H, right? So just put an H there. Now we need to find the height, okay? Because it says height of B above the level of A. What that means is the vertical height, which is H. Okay, now there's two unknowns. We have D, which is unknown, and H. Okay, now if you remember from your sort of standard diagram, you have this is your D, that's your H. Okay, now what we're gonna do is we're gonna find D in terms of H. Okay, because we need to find H in the question. It says find the height. So we want to get rid of D. Okay, so what was your angle? It's 2 degrees, so that's 2. Now, using SOHCAHTOA, sine equals opposite over hypotenuse, which means D equals H over sine 2. Okay, so you change this D minus 3,000 H over sine 2 equals okay, so now the only letter here is H. Okay, so we can just solve this. Okay, so in your calculator, do minus 3,000 divided by sine 2. That will give you a decimal, okay, by H. And then move this to the other side, take H common, and you should get H equals 10.2. Okay. I'm short of time, so I'm not going to do the whole calculation. Okay, going next. Okay, question 4 from the topical. So um, let's see what we have here. Now, this is an energy question, so we are going to use the energy work formula. Look, this is in joules, okay? That means it's work done. Okay, so they're telling you, okay, read it from the start and then we'll go through it. Right, so um, let's see what we have here. So we've got train of mass 150,000. There's a driving force. Okay, point B on the slope is 500 meters beyond A. Right, so what that means is this is this is 500, right? Because it's 500 meters beyond A. It's not saying 500 meters above A, right? It's saying point B on the slope. Okay, so that's 500 meters. Now, remember, this is your distance. Okay, and this is your H. Now we have the distance and okay, let's fill the formula, right? This is D there, distance. Okay, so work done by driving force is what? dF times D, okay, which is going to be, in this case, 16,000 times 500, okay, minus work done by resistance. Right. Now they've told you the work done by resistance already. Okay. This is basically 4 times 10 6, which is 4 and 6 zeros. Okay, remember, this is not the resistance. This is the work done by the resistance, or work against the resistance, same thing. So we don't need to do resistance times distance here, okay, because they've given you the whole thing together. Yep, can you see that? Okay, KE change will be half times M times 42 square minus half times M times 45 square. Okay, now do that in your calculator. You should get, okay, so that's KE change and GPE change. Now, for GPE, make sure you know whether it's positive or negative, okay? Now, in this case, it's going up, right? So it's going to be positive. GPE changes MGH, okay? Now, MGH will be 150,000. Okay, I'm going to cross this for 150,000 times G times H. Now, we don't know what H is, so this is slightly tricky. Okay, so let's try to find H. Remember, this was 500, which is D. This is alpha, that's H. Okay, so using SOHCAHTOA, sine alpha equals opposite over hypotenuse. Okay, so H equals sine alpha, sorry, 500 times sine alpha. Okay, now the reason I've converted it to this is because they want you to find they want you to find alpha, the angle, right? They don't want you to find H. If they wanted you to find H, we could have just used the formula here, rearranged it. We didn't really need this diagram. But because they want you to find alpha, which is the angle, okay, I'm going to change that to 500 sine alpha. Okay, so that will become, let's drop this off. Right, so let's calculate this. So 16,000 times 500. You can do this in your calculator, right? And you should get, so you should get alpha equals 1.8 once you do the sine inverse. So next one is question 6 from the topicals, and again energy question. So I've got the formula there. You should also write it down as soon as you see an energy question. Right now, if you read the question, pause it, read it, underline the keywords, and then we'll go through it. Okay, keyword over here is projected. Okay, now projected means it's launched. Okay, it's not like you're constantly pushing it or constantly driving it. You've basically thrown it and left it. Okay, so what this means is there's no driving force on there because once you've launched it, you left it. It's traveling on its own. Okay, so projected basically means your driving force will be force is also zero. Okay, then we have work done by resistance. Okay, now plane is smooth. Smooth means no resistance, so that's basically zero as well. Okay, KE change now. Um, it's projected with a speed of 20. Okay, so what that means is your U is 20. Okay, and the model we're doing is that it will come to rest. So V will be zero. Okay, so your KE change will be half times M times V square is half times M times U square. And your GPE change is MGH. Okay, now again, this particle is moving up. So GPE will be positive. Okay, so M times G times H. Okay, now let's simplify the formula. So 0 equals um, okay, so this is what you've got. Now, in the question, they asked you to find the distance the particle moves up the plane. Okay, so what they're basically asking you is, what is this distance here? Because this is the distance up the plane. They're not asking you for the vertical distance, right? So this was H. This is 30 degrees in the question. Okay, now, because they're asking you for D, we need to convert H into D somehow, right? So use your SOHCAHTOA. Okay, so sine 30 equals opposite over hypotenuse. Sorry. So H equals D sine 30, right? And sine 30 is half basically. So H is equal to D over 2. And we then change this. Change H into D over 2. So 0 equals 180 over 2 is 90. And if you solve this, you get D equals 40. Next is question 8 from the same document. And okay, so here this question involves power, right? So this is the power formula. Power equals driving force times velocity. Okay. Now it says show that the power is 55,500. Now we can't use this value, right? Because this we need to show. We need to. This is going to be the answer. So we can't use this. So power we are calculating. Okay. Driving force we don't have. Velocity is 5. Okay. So in order to calculate power, we need our driving force somehow. So to get our driving force, let's use the diagram. So we've got a lorry here. Okay. This is your driving force. This is your resistance, which is 1500. And which weight is left? This is the weight, which is 20,000, right? Because you multiply it by 10, which is gravity. Okay. So the component going this way will be 120,000 sine theta, right? Because that's theta and right now they've told you that sine theta is 0.08. Okay, so we're going to use that. Now, the lorry is moving, sorry, the lorry is moving up, right? So we're going to do up the slope minus down the slope equals ma. Now, going up the slope, we only have the driving force. Okay. Going down the slope, we have 1500. And also going down is your 120,000 sine theta. Right now, ma is going to be 0 because it's a constant speed, which means acceleration is 0. Okay, so that is just going to be 0. Now, let's calculate this. So we know that sine theta is 0.08. So we can substitute that into here. You do 120,000 times 0.08. Okay, which is 9,600. So that means your driving force is 11,100. Okay. Once you've got this, put it into here. And that should give you 55,000, right? Which is the same as that. Okay, so part B is this. This is part B, right? So we've got when the speed is v, the resistance is kv square. Okay. Now, when the speed is v, right? So when the speed was 5 that they gave us, right? So we put 5 into this equation here, kv square. Okay, so when the speed is 5, the resistance is 1500. Okay, so that means k times v square equals 1500. And then if you solve this, that will give you 1500 divided by 5 square. So 1500 divided by 25, which is 60. Okay. What they're basically saying is your resistance is equal to kV square. Okay, that's what the question is saying. Resistance is kV square, right? So R equals kV square. From the question, we had R 1500 and V5 substituted in K equals 60. Okay, now the lorry, sorry, part triple I. The lorry now moves at a constant speed on a straight level road. The engine is still working at 55.5 kW. Now remember, this is the power, okay, because it's in watts. So this is the power formula. Now, because we've changed from a slope. Remember, this was a slope, right? Inclined at an angle. And now we are on a straight road. So both of the driving force and velocity have changed. Um, Usually the velocity stays same and then the driving force changes, but because we've changed the surface angle, both of them will change. Okay? They've told you the power is still the same. So 55,500. Sorry. Okay, now, if you go back to the double I, we had R equals kV square, okay? And K is 60, right? So what that means is R is equal to 60 V square. Okay, so we've got 60 V square. This is your driving force. Okay, now, because it's constant speed, that means A is equal to 0. Okay, so your driving force will be 60 V square, right? Because right minus left equals 0. Driving force equals 60 V square. Okay, so driving force is 60 V square times V. Okay, so that gives you 60 V cubed. Okay, and to solve this equation, you divide by 60. Yeah, and then you do the cube root. Okay, and that will give you your speed, velocity. So we're going to stop there and try the next few questions. If you're stuck, write it in the comments and I'll try my best to explain.